So last time I asked you to work on page 15 in your packet, and we're going to go over the answers now. So the first question, number 3, use the following equality to form a conversion factor in order to convert the speed of the cheetah from question number 1 into the units of miles per hour. And they give you the information that 1 meter per second equals 2.24 miles per hour. So if we're going to convert those over, they have actually a typo here on the sheet, but you're going to take the 25 meters per second that you obtained in the previous question for the speed of the cheetah and multiply it by 2.24 miles per hour divided by 1.0 meters per second. Your meters per second here cancel out and you end up with 56.0 miles per hour. Number 4, they are asking you to use these two conversion factors in order to convert the speed of the snail to units of miles per hour. So the snail moves at a speed of 11 feet per day, and so you can convert that using this 2.83 times 10 to the 5th feet per day into meters per second, and then using the other information, convert it into miles per hour. And I just want to comment, I do not expect you to know how to do these on your test, okay? This is just kind of a little tiny intro into it. We're going to be doing a lot with conversion factors the second semester in chemistry. At that point in time, we're going to work on that very diligently, but right now, we are not going to do much with it. There may be a few other problems as examples that you see in some of my videos, but I do not expect you to be able to do these on your own, okay? So just to kind of rest assured, you don't have to panic. This is not something I'm going to expect you to know how to do right now. Number 5, Lisa Carr is stopped at the corner of Willow and Fingston Roads. Lisa's borrowed car has an oil leak. It leaves a trace of oil drops on the roadway at regular time intervals. As the light turns green, Lisa accelerates from rest at a rate of 0.2 meters per second squared. The diagram shows the trace left by Lisa's car as she accelerates. Assume that Lisa's car drips 1 drop every second. Indicate on the diagram the instantaneous velocities of Lisa's car at the end of each 1-second time interval. So if we look at this, and we remember that the acceleration is basically the change in velocity per unit time. That means that with an acceleration rate of 0.2 meters per second squared, that's the same as a velocity or change in velocity of 0.2 meters per second every second. So if she starts at rest, the next second she'll be at 0.2. And then the following second, she'll add 0.2 to that and be at 0.4 meters per second. The next second, she'll be at 0.6. Next second at 0.8. Next second at 1. Next second at 1.2, etc., all the way through all of this. So this is just trying to help you remember the definition of acceleration. So then in number 6, we have 4 different data sets, and we're going to take a look at determining the acceleration of the object whose motions are depicted by those data. So in the first one, since this, again, they're all uniform motion, I like to use by the first one, 28 minus 32 would be a -4, and that would be 4 meters per second squared. They did the total being 8 minus 32 divided by 6 seconds, and you also get -4. If we were putting forwards and backwards here, we would assume that the objects would be moving forward, so their acceleration here would be backwards because it's slowing down, which makes sense. Data set B is also slowing down, so we have at 1 second, 8 minus 12, which is -4, so -4 meters per second squared. They also showed it as being over the whole time interval, which is 0 minus 12, divided by 3 seconds. They also get -4. And again, if we weren't using negatives here, we'd be putting backwards. Data set C is also slowing down. So again, it would be backwards and we should end up with a negative number. 21 minus 24 is minus 3 divided by 1. Or you could take it over the whole time interval, which would be 6 minus 24, which is negative 18 over 6. So, and all of these have units of meters per second squared. And then the last data set, the velocity at 1 second is 24. So 24 minus 32 would be minus 8. And that would be divided by 1 second. So you end up with negative 8 meters per second squared. They also could do it over the whole time interval. So you have one MOP app to work on, which is going to be similar to all of this. Position time and velocity time data analysis, looking at it in the charts. Pay careful attention to the headings because like we saw back here, we had one of our charts had position and time data and the other one had velocity and time data. And when you're figuring out your acceleration, you don't do it the same way. So pay attention, read carefully so that you get all of the answers correct. And please remember, as you're doing some of this, just pull out a scratch piece of paper, because if you're doing these calculations and trying to do them all in your head, some of you might have an easy time of that, some of you won't. There's definitely a few problems in here that I typically take a note of and do the math. So don't feel bad for taking out a piece of scratch paper to write that information down. And when you come back, I'll resume the next video with going over some summary sheets.